Hello everyone. Today I will be taking you through calculus and we'll be working with differentiating using the first principle. So the problem for today says that given the function of which is f at x that is equal to x to the power of 3, I'm required to determine f prime x using first principle. Solution. Alright. On your question paper, the last paper on your question paper, you will be given the formula sheet, and there will be formula written f prime of x is equal to limit as h tends to 0 f at x plus h minus f at x all over h. So this is the formula that will be there on your formula sheet. So we will be using this formula to find f prime of x. Okay, how do we find f prime of x? Alright, since you know that f at x is equal to x to the power of 3, what you have to find is f into x plus h. How do you find that? Whenever you see x, you replace x with x plus h. So here it is x to the power of 3, meaning we'll be working with x plus h to the power of 3, which is equal to, it's x plus h, x plus h, x plus h. Okay, here you have x plus h. If you multiply this one, you get x squared. You multiply x and h, you get x, h. You multiply h, you get hx. You multiply the two, you get h squared, which gives you x plus h into x squared plus the two are equal, xh plus hx gives you 2xh plus h squared. So if you multiply throughout again, x times x cube, you get x cube, x times x squared, you get x cube, x times this one, you get 2x squared h, you get plus x h squared plus x squared h plus 2x h squared and then plus h cube. So as a result, you end up with x cube. So you add like terms, this one and this one, they give you what is 3x squared h, and when you add the two, they give you plus 3x h squared plus h cube. So now you have f at x and you have f at x plus h. So you will use f at x and f at x plus h in this formula given to you. So here f prime of x is equal to, it's a limit as x tends to 0. So instead of this one, this is what will replace f at x plus h, because I know f at x plus h is equivalent to this equation. So it would be x cubed plus 3x squared h plus 3x h squared plus h cubed minus, if you can look carefully here, f at x is x cubed, so it's just minus x cube all over what? All over h. So now let me look, do I have like terms? Yes, I do have like terms. So the two like terms cancel, then I'll be left with, it's a limit as, okay, not x is h here, as h approaches 0. So I'll be having 3x squared h plus 3x h squared plus h cubed all over h. Is there anything that I can do? Yes. I have h, meaning I can factor out h, and then h and h divides. Alright? So it's a limit as h approaches 0. If I factor out h, I'll be left with 3x squared plus 3xh plus h squared all over what? All over h. H and h cancels. Is there anything that looks common? Nothing. What is left for me now is to let my h to be equal to 0. Once I decide to let h to be equal to 0, that way I won't have to write the limit along the way. So as the result, here I'll be having 3x squared plus 3x, instead of h I replace it with 0, plus 0 to the power of 2. So if you can look carefully here, this one vanished to being 0, this one vanished to being 0, then the answer becomes 3x squared. So f prime x is equal to 3x squared. Thank you.